Intro. Hi everyone, I am Deba, and with me I have Anand. I work as a founding engineer focusing on development and growth at Parseable. Apart from work, I am also an open source contributor for a brief period of time. I was a maintainer of Kubernetes project. I contributed to Backstage and over to Anand. Yeah.
Hey everyone, I am Anant. Uh, I am a founding engineer at Parseable and primarily I work with Rust. Or if I'm not dishing out any GitHub issues, you'll probably find me thinking about which game to play next or running around Cubbon because being a citizen of Bangalore, that's what we love most. So yeah, let's start.
Cool. So today our topic is about debugging AI agents in production. So we had a talk where we understood that how current tooling are not the right status quo to understand how agents and models function. Right. For what I want you all to focus here is the production. Right. If you're running a model or preparing a model or an agent to go to production, you have evals, you have inferences to fix the prompts, system prompts, and get the KV cache in place and all those. But once it is in production, right, how do you monitor them? What we have until now, for talking to our customers and users, we have got is it's not a tooling problem. It's about how we use those tools. Currently, like a lot of frontier labs come with a lot of models, and we are yet to see any frontier lab define a new data type for a new telemetry that they say, okay, this is the you logs, metrics, and traces is not sufficient. This is the new kind of telemetry you use. The only thing that has come up in last few years is evals. That is just to test your models before releasing it in production. In production, we are still there with traces, context graphs, and all those, and those can be defined using the telemetry that is available like in last 10 years, right? So let's get started. Basically, the premise here is when we are talking about agent and models, these are a probabilistic component, very different from the deterministic set of components that we have. And the way we use currently instrument our code or we set up observability is to have a signals for what is the internal state of your services or infrastructure. So for example, the 200 OK we get or 500, that state that is a signal for a state whether your API call went through or your API call didn't go through, right? Now we all kind of have a muscle memory of, okay, what does this exact signal determines, and that is in a deterministic flow. But what we forget to instrument when we are putting an agent into production is what is the exact reasoning that the LLM went through before coming to a problem. And that's when we after releasing it into production, you get all these kind of issues. What do you think? ChatGPT, before releasing ChatGPT, OpenAI didn't test 4 plus 2 equal to 6. They did, right? But there are these are the certain issues with LLM that are fundamentals. You cannot do anything about that. But then there were hallucinations, which even though you put in evals or even though you put in a good system prompt, those will be there, because here we have to understand uh, what is for the exact same set of input, the output might be different, and the output will be different in 100 try as well, right? So this is a similar scenario, right? You put your agent and you go to your agent logs and you see all the requests are getting accepted. There is health probe is okay, P99s are okay, but you see from field those agents are not functioning properly. And there are three ways, right, from the field what we've seen how the agent fails. The first one is my personal favorite, wrong but confident. So because of LLMs, because how the models have advanced, we all like to venture out into a field where we are not confident enough. And if you see when Anthropic released the paper for Opus, right, they said how Opus used to go and reverse engineer the test for a benchmark to prove that it is itself like it is the best in that proper benchmark, right? So that is what this model does. Model looks for a shortcut, and let's say you are testing a function, it might create a test case for this. The function is all good, and it says, yeah, it's all good. And as an engineer, you're excited. Okay, 5 minutes it took, and okay, now it is all well and well good enough. Now in agentic system, right, we have something called tool calls. For anyone who is writing code using Anthropic or ChatGPT, you see a lot of tool calls happening. The the best tool is bash, right? You will see a lot of bash tool calls happening for it to just understand the path of your file, right? Now sometimes what it does, let's say you have built certain tools, customized tools for your agents, we try to give kind of similar kind of names to those tools, right? And it hallucinates and it gives you a tool that is non-existent. So this is an interface problem, right? It is your interface is not well glued, where it is not able to understand which tool to call with the given context it has. Now then there is this thing called a loop, a timeout, empty response, retry storms. This is very common, right? When it is stuck in hallucination, it tries a retries, and retries are costly. And this is like it hides in your queue depth. You are unable to understand what is happening because maybe it took 5 minutes and you just put a long running agent and went back and are doing, because a lot of context switching happen when you are using agentic systems. You are doing something on one window, on something on the other. 5 minutes it passed, but it might be successful as well, but the token usage, that is where you lost, right? Now, so traditional monitoring and what we have now, right? For traditional monitoring, the status quo, what I told about, right? It's all about, at core, the observability is about setting a state, like giving a signal based on the internal state, right? You get an external signal based on the internal state, and that's how you know how your systems are functioning, how your infra is functioning. But when it comes to this non-deterministic multi-step, right? The focus on this. The bug lives in the model's reasoning. You need to understand what exactly the model thought or reasoned with the given context for it to come to this particular answer. The reasoning might be different for the exact input, exact system prompt, and the exact input that you asked and an engineer B asked. And because it might be calling different tools, and the bash tool that it called in the previous step, it has done 3 bash calls, and in the previous instance it did 5 bash calls. So the context it gets is very different, right? So what observability actually means, right? This is fundamental to anyone who is making a system observable or anything. Is at core, observability is basically that you should be able to reconstruct a scenario which happened when you were not there. Imagine that your 2 a.m. on calls or like random pagers that comes up, right? You didn't know when that like error occurred or what went wrong. You have to now come and reconstruct this. This is the fundamental for what, how do you observe LLM? How do you observe agents? How do you observe models, be it production, be it in non-production scenario? Now, when it comes to agent, right, there are 3 things that need to be glued together. One is the LLM, second is the tool, third is the agent. Now, this has to be glued together in a proper manner. Basically, today we'll be talking about traces. So in each trace, the step traces should have a proper parent and child combination and in a sequential manner. Otherwise, if you only focus on tool calls and the error in the tool calls, and you don't have the context why this tool call happened in the first place, you are actually starting abruptly in between, right? You can never get into the real bug or what basically in production, right? What you observe, you take it into your pre-production and start improving the things, right? In production, you cannot improve things. You just observe, okay, system has gone wrong, this has done happen. I might have to use a better system prompt. I might have to change the model or anything, right? But you need to have an entire context, whether the model is wrong or whether the tool call is happening faulty or whether it's a right tool call, but your tool is faulty itself. You need to write a new tool maybe, right? So this is how it looks internally for us when we are building the context graph for a single agent invocation. I want all of you to focus on the shape, the topology of the trace rather than on the times or on the values, right? Now, if you see one color schema, right? Tool refund order, it hallucinated and the arguments that came out was incorrect, right? Now, in a standard way that we do today instrumentation or we understand our dashboards, fundamentally we look at the numbers, the duration, right? What was the span duration? Whether the span duration was long or whether the span errored out. Now, if you see, right, the span did error out from the argument. The span was successful, but I mean, the tool call happened. It was successful. The argument it came up with was wrong. Now, when we go on the recovery cycle, this is where it gets interesting. In a deterministic flow, the recovery cycle would have been a next API call. But in LLM, it's a the recovery is the next LLM call, which is more time consuming. More time consuming means more tokens have been utilized, and that is a costly affair. And that is not the path you want to walk through, right? Now, with whatever I have discussed, right? One thing I have been focusing till now is the standard tools that we have available currently is the right tool for us to do LLM observability, to do agent observability. And here we are focusing on agent observability. And when we go, there are a lot of tools that you find in the market that have come up with their own agent SDKs, where you can go and instrument your agents automatically and then get the traces in their dashboards. And your system is observable, like you are happy. But what you are putting into risk is a standard, right? A standard is sacrosanct, right? It has come up through years and years of adoption in large tech, small techs, and OpenTelemetry is one such. And if someone who have been using OpenTelemetry since a long time, if you are following the semantic conventions for a long time, they release various semantic conventions. Few semantic conventions are still in beta, and minded semantic conventions are suggestions. These are not the sacrosanct attributes or span names you should use, right? For Gen AI, they have something called Gen AI dot star, anything like model name, tool usage, caching, and all this. And anything, right? Any OTLP backend that says we are OpenTelemetry compatible. If you're sticking to this OpenTelemetry standard, it becomes usable, right? Today you are using Grafana dashboards. Tomorrow your stack grows. You move to Datadog. You fail to pay, like you are feeling crunch and money in Datadog. You come to tools like Parseable. The backend understands a single language, that is OpenTelemetry, right? So the demo we will have today will actually show you OpenTelemetry semantic conventions that we have used to do agent observability, right? Now, for all the engineering orgs that I've worked with till now, right, when it comes to writing tests for your code, when it comes to instrumenting your code, that almost always is inversely proportional to the sprint load or like the velocity in which you want to ship. Now with LLMs, with agents, with all the smart IDEs that you get, the ask for velocity is very high, right? Everyone wants to see fast, and you want to write code. You want to write meaningful code. That's it. And then if you've seen, right, historically, anytime the velocity is high, especially around the end of quarters, your code coverage falls down. The same is true for instrumentation. If you tell someone to spend 1 week, 2 days, or 3 days to do an instrument or write a boilerplate that works for 2 services, you write another boilerplate for 3 services, that is just not enough. And from when we come from, like, we sell observability, right? Observability tool. All our customers have to first instrument, and it is true for all the kind of observability tool you use. Instrumentation is the core. If you don't instrument it properly, you lose the maximum amount of time while debugging, or you don't you get a lot of garbage data, and compute and memory is really like really costly, right? Now, what we have come up with is a way to auto instrument both classical and agent as well. What Anant will show you is how we identify the code base, the entry points, and everything, and auto instrument it for you. We understand what is your code base, where your DB calls are happening, what are your endpoints, and then what we do is we don't change your business logic. We just like we are only instrumenting it for traces. We put span in places, and all your calls are like wrapped through spans, and those spans then go into step traces, and we do a call chain, proper call chain for your functions and for your endpoints. Over to you, Anand.
Thanks a lot, Deba. All right, so just a quick overview of what OTEX is and what led us to it. So, like we all know, OpenTelemetry is a pretty new standard. And what it offers is a set of guidelines that the onus of following them lies on us, but it does not enforce those guidelines on us. So, while talking to clients, we realized two important things. Firstly, no one likes to instrument manually. And secondly, if you are asking them to instrument manually, uh, making them follow those guidelines is really difficult. So that is where OTEX comes in. OTEX is a VS Code plugin. It interfaces with your code by just sitting right there where you're coding. It takes 4 steps to go through your code base, figure out what it needs to plan, and just present you with it. So these are the 4 steps. The first one being analyze, then planning, then instrumentation, and then commit. So in the interest of time, I'll just quickly take you through what these 4 steps look like. So over here, I have this famous Rust repository called TensorZero. and I have OTEX already loaded. So if I were to analyze this code base, I would see that I get a bunch of endpoints that it was able to find. So in the background, OTEX communicates with the LSP, which is the language service provider. In this case, it's the Rust analyzer, and it surfaces all the endpoints that are present in your code base, and just provides you with a list of all the services that are there. So you select a couple of endpoints which you want to instrument and just click on start planning. Since planning takes some time, I will switch over to a window where we have already planned. So planning is a meticulous process where it goes to the code base, try to figure out, have you already set up instrumentation before? If not, it will ensure that the correct dependencies are added, the correct modules are added. And while going through the call chain, it will also come across utility functions which may or may not need to be instrumented. So if let's say a util function is just incrementing some counter in memory, you probably do not want to instrument that. It's a waste of your time. So this is what the planning step would look like. And if we were to approve it, move on to actual instrumentation, this is what the outcome looks like. So you've got, that's me over there. You've got your endpoint, which I selected for instrumenting, which is query. And the end result is it added this telemetry module because I did not have telemetry or any sort of instrumentation setup. It added the dependencies which were required for instrumentation. And if I were to look at the diff, so it added traces where they needed to be. And it also created empty spans and then filled them in as we got that information later on. So this is what your classic instrumentation would look like for a classic code base. But since we are talking about agentic instrumentation, so I'll take you over to Parseable. Over here, we have this section called agents. And in agents, you are going to send data which was instrumented for your AI agent. So just a quick overview of what your, how many sessions you've had and how many total tokens you have consumed. So yeah, this gives you a holistic overview of what the agent is doing. And at the bottom of the screen, we have all the invocations that were made by the agent. So let's say this is SWE agent, which is a quite popular open source benchmark. And let's see. Let's look at the invocation. So invocation for this was just to fix a small syntax issue and open a PR. So the agentic observability from our POV is a series of calls. We are able to see what the parent span was, what the child span are, and you're able to track everything that your model is doing. In this case, the agent was using 4O mini, and we see that the 4O mini was unable to make a string replace call over here. Now imagine if there were cascading errors, you would probably not get to know if this was not instrumented because the end result is still a success. It's still a 200 OK. But in your POV, it is still doing fine. But the the cascading tool failures, all they will get reflected in your user's bill. They will see increased token usage, increased billing, and probably increased time consumption as well. And you'll start to lose customers. So yeah, this was just a quick overview of what the agentic observability looks like. Now back to Deba.
Yeah. So what we saw is basically a lot of OTLP backends can do if your agents are or LLMs are instrumented properly, right? You can send it to your trace viewer itself, classical trace viewer, or build a dashboard on top of your trace viewer. But you need to instrument as well. Instrument it well is where we come from, right? So then there are a few fundamentals you need to understand when you are dealing with an agentic system. Span every LLM call because your prompt is code, and each code that is not logged is inauditable. So if you don't have the prompt that you and your system sent, and you just have the tool calls that became successful per invocation, you are actually going half blind, right? Then wrap every tool with logs and arguments that we saw in the demo, right? One of the tool call failed, right? If I don't wrap every tool, if I miss some of the tools and just put on important tools, I will miss on that particular error, right? And trace one trace per agent run. So this is a common issue that I find, right? When people try to auto-instrument it using just Claude or ChatGPT. Basically, what these LLMs do is basically they will create one span without any parent or child for each of this call. Like each tool call will be a single parent span rather than having being part of a larger agent invocation call and be a child span. And that is where you have this analysis paralysis. The data you are getting in is not meaningful for you. When you're going to debug, you have to go through a lot of trace IDs, take the span ID, match with the parent trace ID, and those things go on and on. Then alert on shape, not on status. So this is something that could be better. Like shape is not, topology is not something that can be quantifiable in a scalable system. But currently, this is the status quo. This topology gives you much better answer than the status quotes. Right? So before concluding, right, I want you to understand few things, right? There are various places where you need to focus on. First of all, the reasoning, whether your model reasons well for the particular case, because there are zero shot forecasting model that works very well for like time series data scenarios, or there are generalistic models that can do that can also do that same stuff. You need to understand what model work for you, and that you can only understand going through the reasoning and the output it came from. And patterns, right? You need to identify patterns. What do I mean by pattern, right? Let's say you are on call, you wake up on a Monday morning 6 a.m. To a page. The workflow, the mental model you remember about debugging is what is the pattern. Identify those patterns and automate it. Whatever you remember as that pattern is very sacrosanct and very important, because apart from that, whatever information is given in a Notion doc in a one pager is useless, right? At that point of time, it's a mental model that you form first and go through debugging. And auto instrumentation, right? If instrumentation is something that your engineering team has to do when it thinks it has time, you are already failing, right? It has to be part of your workflow, and that only way to go there is auto instrumentation. And auto instrumentation is quite prevalent if you do Kubernetes monitoring today. OTel SDKs are very good at auto instrumenting, but what in agent, there's still time to come up with that kind of automation, and that's why we build the OTels. So before I conclude it, I want all of you to go to your orgs or go to your companies and pick an agent that you are more nervous about and see whether you could trace a single agent call end to end, right? Reconstruct an agent call from end to end from the time you have given the prompt and to the result without the help of the engineer who has built that agent and given it to you. If you're able to do it, well and good. If you're not, then you know where to start. Thank you.